Section 4 is going to cover acid and base nomenclature, so that's how to name acids and bases. Okay, so we'll start with naming acids. There are two types of acids. It's either a binary acid or an oxyacid, and we're going to start by learning the rules for naming binary acids. So, how do you identify the difference between a binary and oxyacid? Well, a binary acid contains hydrogen and one other element, or just a single polyatomic ion, which we'll see here in just a moment. Okay, it generally starts with H followed by some other single element. Okay, rules here is that, so for number one, the first word has the prefix hydro to name the hydrogen part of the compound. The rest of the first word consists of a form of the root of the second element plus the suffix ic. Okay, so whatever X is here, we name that element and change the suffix to ic. And then the second word is always acid. Okay, so here's one to identify, right? H and then some element, H and then some element. So we start by naming the H part of this hydro. And then we're going to take the root of the second word. So this is chlorine. So we're going to take chlor, and we're going to change the suffix to ic. So this is hydrochloric, and the second word is always acid. Okay, so you might have known HCl was hydrochloric acid, but that's the formula that it follows. HBr starts with hydrogen, so it's going to be binary. It's just hydrogen and one other thing here. So that's going to be hydro, and then bromine's root is brome. We're going to change the suffix to ic, so it's hydrobromic acid, like that. You might occasionally see some examples of things that follow binary naming, but they're not just H plus one other element. Generally, how you know this is the case is that there's no oxygen in the polyatomic ion. Okay, because those are going to be oxy acids, which you'll see here in a moment. So this example here, HCN, there's no, or if we split this, okay, there's no oxygen in my anion here. This is a cyanide ion. So we're going to name this in a similar fashion as we did HCl and HBr. We start with hydro, and CN is cyanide. So the root of that is cyan, and we're going to change the suffix to ic. Okay, so this is hydrocyanic acid. All right, so even though this isn't just a single element, there's no oxygen in it, so we're going to apply the binary rules here. We're not going to see this too frequently, but just be aware that it can happen. Our other type of acid is an oxyacid. So this is an acid that contains hydrogen and an oxy anion. So remember, that's a negatively charged ion with oxygen, right? Okay, so it's got to have a negative charge and it's with oxygen. It's called an oxyacid. So these are things like ClO4 with a -1 charge, ClO3 -1 charge, Hno3 with a -1 charge, Hno2 with a -1 charge, right? Got oxygen, negative charge. The rules here, so this time around, identify the oxy anion present. The first word consists of the root of the oxy anion and any prefixes, so including like per or hypo, if necessary. The suffix depends on the oxy anion's suffix. If it ended in ate, the new suffix is ic. If it ended in ite, the new suffix is us. And then the second word is always acid. So we'll look at HNO3 and HNO2. So we need to identify the oxy anion present. If you're not sure what it is, right, separate the hydrogen from the oxy anion. I have NO3 here. That is a nitrate ion, right? If you look on your ion sheet. So you're going to need your ion sheet for this assignment. That's a nitrate ion. So what are we going to do here? We don't need to add hydro or anything like that. It just says the first word consists of the root of the oxy anion. So this is nitrate, so that can be NITR is the root. And then we're going to change it if the suffix ended in ate. The new suffix for the acid is ic. Okay, so NO3 nitrate is going to change to nitric, and the second word is acid. So that one is called nitric acid. Okay, the one right next to it, HNO2, if we separate that out, NO2 is a nitrite ion. Okay, and we're going to change, right, this time the suffix was ite, and so we need to change it to us. So as an acid, HNO2 is nitrous acid. So it just depends on the ending of the ion. Ate changes to ick, ite changes to us. We'll see some examples here in a moment of what happens if it's like ClO4, because that's got a per as a prefix in the name of that oxy anion. Okay, so let's talk about ones where we've got multiple oxygens and possibilities here. HClO4 is perchlorate ion, perchlorate, okay? And when we change this, the 8's going to change to ick. So this as an acid, right, so if I split that, the ClO4 is the perchlorate ion. This is going to be perchloric acid. I kept the prefix per, but I did change the suffix from ate to ick, okay? HClO3, ClO3 is a chlorate ion, right, from your ion sheet. We don't need to add any prefixes here, so that's going to be go back and change that. That's going to be chloric acid. We changed the ate to ick. And then here, HClO2, this is chlorite. So changing the ite to us, that's going to be chlorous acid. And HClO, this is a hypochlorite ion, hypochlorite. We keep the hypo, that doesn't change. Hypochloric, there we go, acid, okay? Just things to be careful of here for oxyacids, do not use hydro. Do not do that. The amount of times I get guys that try to go like hydroperchloric acid. No, hydro is just for binary naming. Do not try to apply it here. You just find the name of the oxy anion and change the suffix. That's it. Here are some exceptions to the oxy anion and just the generic rules for acid naming. They come close to following it, but there's just usually something slightly different. H2SO4, so if I separate out the hydrogen from that, I get an SO4 ion, which is a -2 charge. That is a sulfate ion. And so you might be tempted to say, well, that 8's going to change to ick, and so this is sulfic acid. That's not what this is going to be. It's very close, though. This becomes sulfuric acid, which you've probably heard of before. It's battery acid, sulfuric acid. Very similar here, H2SO3. That's an SO3, right? That's a sulfite ion, right? You would think that might be like sulfus acid based on our conventions for naming. No, it is sulfurous acid, right? So it looks just like the one right above it there. H3PO4, separating out the hydrogen. PO4 is a phosphate ion. Phosphate, right? And you'd think this would be changing to phosphic acid. It's close, but that's not what it is. This is phosphoric acid. One of the ingredients in Coca-Cola, if you look on the side of that, it's called phosphoric acid. This one down here is kind of odd because this is an acid. Sometimes you'll see the H written in front here, but the actual acid part of it is this H. And even though this has an OH here, this COOH, this is an organic acid, so it's got carbon in it. It ends in COOH. This actually separates out like that. And this is an acetate ion, which you might remember from your ion sheet. CH3COO with a -1 charge. Okay, that's an acetate ion. All right, the naming is actually correct here. So acetate is going to change to acetic acid. You probably know this better as vinegar. Okay, is this formula here. So just be careful. If you see something end in COOH, like this, that is an acid, and it's the last hydrogen that you need to pop off. The rest of it, the left side of it, is actually the anion. So this is an organic acid. You won't see this too often, but just be aware of it, right? So that was an acetate ion. It became acetic acid. Naming bases is really convenient because there's nothing different than what we've done before. Basically, you've got hydroxides and then other compounds. And so if it's a hydroxide, you're going to name it based off of ionic naming rules, right? You're going to use your ion sheet and ionic naming rules to do that. So nothing different there. So if it's soluble and it contains a hydroxide ion, it's just name the metal, then the word hydroxide. So this one, NaOH, name the metal, sodium, and then it's hydroxide, so just sodium hydroxide, right? CaOH2, name the metal, calcium, and then just hydroxide, right? So that's just your old naming rules. There's nothing different about that. That's actually great because it's just the same thing it was in the first semester. And then outside of the hydroxides, of course, you're going to need to use some of your other naming rules. NH3, this is your binary compounds from first semester. All right. This one is going to give us, you can name it two ways. You can either call it nitrogen trihydride, which is its formal name, okay? Or you can call it ammonia, right? That's the common name of NH3, ammonia. And then CaCO3, calcium carbonate. This is just an ionic compound, right? So just use your ion sheet. This is calcium, so that's what Ca is, and CO3 is carbonate. So all you got to do is just your old naming rules from first semester. Maybe if you've forgotten those, go back and look at them. But there's nothing new there, right? That's just old naming rules. So acids have a new set of rules for naming. Bases just use the same rules we learned first semester, so that's really convenient. Okay, here are a couple of them for you to practice with. So first of all, tell me whether it's an acid or a base, and then give me its name. So, remember, is it an acid? Is it a base? And if it's an acid, is it a binary acid or an oxyacid? And that changes how you name it. So go ahead and give these a try.